My session is on security. Security is not a feature. You see the subtitles, or how to build your own security features, how not to rely on vendor-specific features, or how to roll your own security feature just because you know better. These are all not true, and we will definitely get into the point on why and how and what. Quick introduction. My name, Robert Hartskirl. I'm working from Holland. I'm based in Holland. Some of you might say that's incorrect. It should be the Netherlands, although I'm one of those few that can actually say that I'm from Holland, because I'm actually from the part in the Netherlands that's called Holland. 20 years of experience in databases and general IT, and a lot of more experience in other things as well. What I do with databases, and primarily on the Microsoft platform, pretty much anything. I've listed some of the wild, hyped terminology here. I often say to people as well, I just recently did a large Databricks project for a customer. I said, well, what I'm doing here today with Databricks is no different than what I did 20 years ago with data transaction services in SQL 2000. The tools change, but the general process and how we approach things and how we do things, they do not change all that much. So basically, I do everything with data with a strong focus on the Microsoft platform. I also worked 7 years at Microsoft as a field engineer assisting customers with break-fix support on site mostly. But now, 4 years ago, I started my own company together with some former colleagues as well, and today we find ourselves assisting customers with everything Azure and data related. Whether it's Synapse, whether it's Databricks, we pretty much build your new and improved data solution in the cloud. Not because we want to, but because people ask us. Security. Why? Some topics about security, or some things about security that I believe are very important. In my career, I also have a professional career. When I started when I was younger in military, I was in the military at some point in my life, and I've also worked for the Department of Defense. So security is somewhere intertwined in my professional career as well. One of the important things that I've learned along the way is that the danger is not always on the outside. We always trust the people inside, we trust the people we work with, and you should. There's no need, there's no reason not to trust the people that work for you. But there's always these edge cases where something happens that you didn't expect and that you didn't prepare for. We recently in the Netherlands had the same situations, a couple of these situations, where people who worked at a company had access to sensitive data, sold that data, because that data has value. And whenever something has value, there's a quick buck to make, and if you're in need of money, you're a tight spot, then there's always somebody that's willing to sell data or willing to buy data. So if you have access to the data, it means that there is a possibility there as well. The more value your data has, the more interesting it becomes for other people to access that data. I've worked with quite a few companies over my professional career. I've worked with large companies like BMW as well, and they say the same thing. They say there's a lot of countries out there, not even people, but countries out there that want to know what we are doing because they want to use that technology within their own country, because they want to sell better cars than we do, to make sure that they get a huge benefit on this. The same with CPU processors. There's a large factory in the Netherlands building a large amount of CPUs for the entire world. They get hacked quite a few times, or at least try to be hacked, because other countries want to have that same information as well. As I said as well, always it's good to trust your employees, but make sure that they do be aware that they might steal the data for whatever reason they have, and think on yourself, do they really need this access? Do they really need access to this data? Do they really need to see this portion of information? And why? And if they don't, why am I granting them access to it? And a lot of companies I've worked with, they say, okay, but this is the only way the application works. Yeah, okay, that's an answer. And then you want to ask yourself, okay, do I want to be in the newspapers next week? Because this security feature could not be implemented by this application. How important is this? And as I said, I worked for the military as well, and we always had a trade-off there as well. We knew that we had a tight security, but still USB drives got lost somewhere. We knew that these USB drives were not ours, but they were lost by military personnel, meaning that in the newspaper there will be a headline that says, military USB hard drive found in train. We know that's not the case. We know it's not a USB military hard drive, but we know the headline says so, so everybody thinks it is. So that's important to realize as well. Another one is that you can't lose what you don't store. Especially in data warehouse solutions, what I see in data warehouse solutions working with customers is the same as I see with auditing and security. So if you want to create an audit log in SQL Server, you go to your security officer, you ask him, what do you want me to audit? And the answer will be everything. Just audit everything, we don't know if we need it. And then we end up with a huge audit log. The same we see in data warehouses today. Because today in data warehouses, we are not tight on storage. 10 years ago or 15 or 20 years ago, if you wanted to store something, you would think twice about a data type. Is this going to be a datetime or is it going to be small datetime? Because that's a difference in 4 bytes, multiplied by millions and millions of records. That's a lot of storage. But today, that's not an issue. Just dump whatever you want to dump. Let's call it a data lake, hopefully. And let's hope it stays a data lake where we just store everything there. That means you're also storing sensitive information, potentially, that you're not aware of. It also means that you maybe are not compliant anymore. At least here in the European Union, there's a GDPR which says every customer has the right to be forgotten. So if I store all the data that I have from everyone that I have, and then they send in an inquiry saying, please remove all my data from your systems, then that's going to be a hell of a job for you. Also, if you get a breach, if your data gets stolen, then there's a lot of information, a lot of people you have to inform. Yeah, sorry, but we lost your data for some reason. And the last one is encryption and hashing. Hopefully, everybody that stores a password in a database is hashing the password, which is a form of encryption, but it's different. Encryption is 2 ways. I can encrypt something and then decrypt it. Hashing is 1 way, and hashing is better suited for passwords. But you don't only have to encrypt and hash passwords. You can encrypt all the data in your database if it makes sense in your use case. Credit card numbers don't have to be stored readable in a database. Maybe I want to have them visible on my screen when I access customer information, but it doesn't mean that I have to store them visible inside a table where potentially an administrator can read them, or whoever has access to the actual storage can look into the page on disk, open it up in Notepad or a hex editor, and then actually see the data there. Some security features that you might use or may or may not use, but they are available since SQL Server 2016. I can even recall that I did a demo on all these features when SQL Server 2016 came out. Dynamic data masking, row-level security, and always encrypted. These are just 3 examples. There's a lot more, and every version of SQL Server has different security features added to it as well. Dynamic data masking. If you've never seen it, potentially, or what it does, it masks data inside a column. So you have a column that you specify. Maybe you have an email address in there. Maybe you have a bank account in there. And what you typically want to do is to not expose the entire bank account, but only expose, for example, the last 4 digits. Very common in credit cards, where we only see the last 4 digits of the credit card, because that's enough to easily identify that this is the correct one. SQL Server has some built-in functionality since SQL 2016, where I just say, this is my column name, mask it with this pattern, and there's a few built-in patterns, and I can provide my custom pattern there as well if I want to. Fairly easy, and then I just random insert some data, and if I select that data, well, then we can all imagine what will happen. The data will be masked as it's being returned to the caller, to the client. Row-level security. What this does in SQL Server 2016 and higher is it allows me to filter record sets in the database. So let's imagine I have a huge table with medical records in there. I only want the doctor that's responsible for his patients only be able to select and query his patients and not other patients. Then we can introduce row-level security, and row-level security will allow us to filter based on a predicate. The way this works is that I first have to create a function, and that function returns a table it's an inline table valued function, returns a table, and that table allows me eventually to get access to that specific data. Usually what you see in all the demos and all the examples is this is based on the username. So we get the username using a built-in function in SQL, user_name, gets me the current username for the logged-in session, and then we check whether or not it's equal to whatever name we have stored in our database, or if it's equal to, in this example, manager. Meaning that if you're a manager, you will see this row, or if your username is equal to the username we have stored on the record, then you will also get that row visible there as well. Once you've done that, you attach it to the table, because this is just creating the function. You create a function, then you attach that function to the table, and then it becomes implemented. So you don't have to do anything more, that's all you have to do. There's a caveat in this as well, because this is based on the username. Meaning that, at least in this example, it's based on the username, meaning I need to know the username from the logged-in session. For example, for a web application, your web application maybe uses a random connection string, and it's actually the web application that's connecting to the database, and not the actual user that's calling into the web application. So that makes it a little bit harder to work with, although, as you will see in my demo in a moment as well, I'm doing the same thing, but I'm still able to change the user while logging in. There's a lot of techniques you can use to do this as well. We can set an application context. There are some things you can do to make this actually work. But you need to be aware, especially in this example as well, it's based on the username that's coming in. Because we need to match whoever wants to retrieve the data with whatever security policy we want to attach to that person. The last one that I want to discuss is always encrypted. So always encrypted works by encrypting the data inside the database and only making it possible to decrypt it on the client. And that's basically what we want. Because from a security perspective, if I have access to the physical machine, if I have access, or the virtual machine, or if I have administrative access to whatever the device is that the data is stored on, I actually own the data. Whatever encryption key is there is in the database. And I will eventually be access to access it. I've done a lot of demos with customers as well, where I say, if I have access to your machine, I can get sysadmin access to your database. And that's a general rule. If I have access to the device, I can get admin access to anything. So storing data inside a database isn't always the safest option. And we want to encrypt that data, and we want to make sure that the data can only be decrypted by whoever has proof of being able to decrypt that data. In SQL Server 2016, this is possible by using Always Encrypted. And Always Encrypted is a technology where, based on configuration in SQL Server itself, and something that's done on the client side. And that's done on the .NET library, which is responsible for getting the data in and out for most applications. What it does, it gets the data from the database. The data in the database is encrypted. It sends the encrypted data to the other side. The client gets the encrypted data. From the configuration, from the connection, it knows what certificate was used to encrypt this data, searches the local certificate store from the user if that certificate is present, and if so, decrypts the data using that certificate. From a developer perspective and from a database administrative perspective, this is fairly transparent. It doesn't necessarily mean I don't have to make any changes to my application, but I don't have to make many changes to my application. You have to do some things, and I will explain these in a moment as well. But this all works on the, it says here in the middle as well, the ADO.NET library, which is commonly used for applications accessing SQL database. It's all done there, nothing happens on the SQL server, and no data is decrypted in transit. So at all time, anywhere in the process, the data is encrypted up until the client, and only if the client has the certificate, only then the data gets decrypted. To put this to action, I'm going to show you a little demo for all these SQL 20 on a SQL 2022 machine, showing how these functions work. What I have done for dynamic data masking, I have taken a very old demo database. Not sure if anyone remembers this one, but this is the Northwind database that I'm using, which was the sample database in SQL 2000 and before that. Before it got replaced by AdventureWorks, and then later by the other ones. So I'm using the Northwind database from SQL 2000, which I had some challenging experience to actually get it to a SQL 2022 instance, but that has been working. That's running. So I have a Northwind database. I put a mask on the customer's table phone column. I'm just using random for demo purposes. You choose whatever you want, but I've created a mask, place that mask on that column, and now the data is masked. The masking that is being used is it's showing an arbitrary number of axes, I think 5 or 6, I'm not sure what I configured, and then the last 4 characters of that string. Not necessarily numbers, the phone number is stored as text, it's just showing random the last 4 text characters from that string. Then for row-level security, I created 3 users that are also in the Northwind database in the employees table, Andrew, Janet, and Margaret. Andrew, if you look at the data, is the VP sales, Vice President of Sales, and then his direct reports are Margaret and Janet, or some of them. What we want to ensure here is we want to use row-level security. We created that predicate is available, and that predicate ensures that if Andrew selects the data, he sees the data from his sales, if he has any, but he also sees the sales from Janet and Margaret. If Janet or Margaret logs in, they see the data that they made, the sales that they made. And then the last one is that I have encrypted the address column. The certificate is installed on my machine because this is all running locally. And then the application needs to pass in the encryption, and then the data gets decrypted. Any questions so far? If you have any, feel free to ask. What I've done, I've created a small application to show this. This is a web application directly connecting to the database, not doing much, and then querying that table. So I'm using the orders table and the customers table. So you see here the orders in a list, and then you see the detail for the orders on the customers table on the card on the right. On the top left, you can see the amount of rows that I have, 648 rows in total for Andrew. So Andrew is able to see 648 rows. On the right, where it has the card, you can see that the phone number has the axis and then the last digits or the last characters, and the address is encrypted. I did encrypt the column, but there's some settings you have to make, change, to actually be able to decrypt this value. So having the certificate is just one step, and that's the only step. Now I can, if I want to, I can click around, and then at some point it will change, and I can see the values for the other customers as well. You can see here on the right column, you can see which employee sold which data, which order, which employee is responsible for which order. Yes?
There is a question from online audience.
Okay.
With always encrypted, can you access the data to extract it into data warehouse?
Okay, so the question is, can we extract the data with always encrypted into our data warehouse? Yeah, basically yes, and I'm going to show you in a moment how I can actually access this encrypted data, because the data is encrypted and I want to access it. The same rules apply there, but then we need the certificate. So that's where it becomes challenging, because if I run in some cloud environment where I'm not running Data Factory, but Data Factory is being run by a third-party service, or actually, in this case, Microsoft service, and the integration runtimes are shared integration runtimes spun up by Microsoft itself, then the certificate is not present there. So then you would not be able to do so. Only if on the client machine that's making the connection, we can install and import the certificate, then it would be possible. Yes?
I'm just thinking because you can have the encryption key in Azure, what's it called? Azure, there's some keys, data certificates or whatever it is.
Yeah, key vault.
Yeah, key vault, yeah. So I guess then ADF should be able to retrieve it from the key vault.
Yeah, well, I would have to check it because I don't know, because it's a very good question that I didn't come up with myself.
In the SQL Server where the key is located. So, yeah, I'm not saying that it's working because I don't know.
No, but it's a very good question. And I think it triggered my mind just as well that, okay, yeah, that's indeed a good one. Hopefully they checked it, but I don't have the answer right now. But it's definitely a good question. And I hopefully, because that would be the solution. I use Key Vault, store the certificate in Key Vault, and then have it pulled from Key Vault dynamically. I'm assuming it works, but I haven't tested it and I don't know it. No. And actually, I'm going to demo this all on SQL 2000 in a moment, so I didn't look into what Azure could do. If I change the user, if I change to Janet, you can see that the orders total changes to 127. Janet made 127 transactions, and the rest stays the same. Also from the employee column, we can see now that we only see the data from Janet. And I can switch this around to Margaret and then back to Andrew as well. This works as expected. Nothing has been done so far on the application side. The application side is just querying data as it was before we actually had row-level security and all these features implemented as well. One thing that you can see is that the encrypted column is still not readable. In order to be able to read the encrypted column, we need to pass that into the connection string. So the connection string that we pass into SQL Server has a new keyword where we specify that we want to leverage always encrypted for this connection as well. I have already done this as well, and I can show you. All I have to do is just flip a switch here where I say true, and then somewhere in my code, I'm making that switch to switch in another connection string. So if I rerun it, the application comes back. And now you can see on the right that the address is now decrypted. So all you have to do is pass in the connection string, say, I'm not sure what the keyword is, something like column encryption with spaces. So it's a really strange keyword because it's not similar to the other ones. But if you pass that in, then you can see the encrypted data if you have the certificate. I'm not going to remove the certificate because it's breaking something else, but I know from the demos that I did in the past as well, if I remove the certificate, rerun it, the data will be encrypted as well. That's an important concept as well, because there's a change you have to do to your application here as well. Now I get the data, I see the data, that means that the data now is in the data type that it was supposed to be. So if I have a varchar column, for example, and I enable always encrypted, then the data is still varchar. Unless I don't have the encryption keyword in my connection string, or I don't have the certificate. Then I get encrypted data, and that's var binary. So your application needs to be able to handle this change, because if the data is decrypted, you get it as the original data type. If the data is encrypted, you get it as var binary. And somewhere in my code, I have this as well. I'm verifying what the data type is. If the data type is var binary, I'm showing that text that says encrypted. If the data is not var binary, then just show the data as what I expect it to be. So always encrypted means you still have to make a change to your application, potentially, to handle that you're not getting encrypted data, that you're getting encrypted data. Yes?
Regarding the dynamic data masking, are there any caveats regarding if you, for example, want to mask clustered index columns that exist in the clustered index or non-clustered index?
Yeah, so are there any things that have to do with data masking in relation to indexes and other things? There's quite a few, but I didn't check all of them because I didn't want this to be just solely on data masking. There's good documentation on the Microsoft page as well, because there are indeed some things that data masking, well, I wouldn't say it right now because I don't know it from the top of my head, but there are some limitations to uses in indexes, using computed columns, and then there actually are some neat tricks that are documented as well on how to actually find out what the data is that is masked. Especially data masking is not a true security feature. It's handy if you want to do this. What I also have done with customers as well is that we want to have developers test with data. So instead of creating dummy data, we mask the data and have them have access to masked data. But that would also imply that we give them access to production, and that should not be the case as well. But that's an issue. And also, if you copy masked data, the destination gets it with the mask, not the original data. So there are some things there. Same applies to row-level security. There's a lot of details there as well, where it works, where it doesn't work, what you need to be aware of. And the same goes for always encrypted. Features may or may not work if you use that. So it's really important to also verify whether or not the functionality that you want, you're still able to get that with these features. So that's just basically, you can get the information online as well. Microsoft has documented this as well, and there's a lot of feedback on how to actually apply this. Now, to come back to what I wanted to tell is, I want to show you that this is not specific to SQL 2016 or later versions of SQL 2016. To be able to show this, I've spun up a SQL 2000 machine, and I can briefly show it to you as well. I'm not going to do the full experience on SQL 2000 because that's going to be very hell and unreadable for most people, because this is also running on an older version of Windows, which has no concept of scaling your screen size and stuff like that. So I'm going to, and actually what the fun part is that Management Studio, I've tried 3 tools, Management Studio, Azure Data Studio, and Visual Studio Code. Management Studio is the only one that can connect to a SQL 2000 machine. Data Studio cannot, and Visual Studio Code cannot as well. Also, in my own code, I have found that it's going to be quite tricky to be able to access SQL 2000. But I made it work, and what I'm going to show you is the features that I just show, the application that I just show, but then running on SQL 2000 where these features did not exist. So, data masking first. So what does it do? It fetches the data from the rows, gets the rows, applies the masking if it's needed, and then sends the masked data to the client. That's basically all it's doing. So if I go back to my sample application, it stopped. Then I can here change my service to actually being connecting to, oh, that's the wrong one, to connect to my SQL 2000 service. So now if I run the application for the first time, it's connecting to a SQL 2000 database. The orders total is 830. If you remember from the previous one, it was a lower number. Now I don't have the row-level security. The address is already encrypted. That's what I have done for the second demo on the encryption database. But I'm showing here a base 64 visualization of the encrypted data. And I can see the phone number is not masked here. If I change to another user, nothing happens, or nothing seems to be happening. Actually, it's reloading the data, but since I don't have row-level security at this moment, nothing appears to be happening. Now, I'm also going to do this while making minimal changes to the application. So right now at the application, the only thing that I did is what I changed the service that I'm using, but that's just some common techniques for developers to do. Has nothing to do with the data. Masking. Here is a view that I'm going to create, or I already created it, but I'm going to make a change to it, or not a change to it, show you how it's done. So here's an alter view. Here I do the select on the table, and then I do a case statement. And the case statement says, if the username is not equal to DBO, the username DBO means the owner of the database. So if you're the owner of the database, I'm allowing you to see the data unmasked. But if you're not the owner of the database, I'm masking the data. And this is also how data masking works as well. And data masking, we can actually specify which users should see masked data and which users should not see masked data. But here we could potentially do something similar. But this is all we do. We take the same amount of access, take the right for portion, and then show that back to the end user. Now I'm going to create this view, or actually I've already created it. reconnect to my database. And now to make it transparent for my application, and this is a technique that I often use as well, not only in this situation, but I also do a lot of talks with developers that say, okay, developing and getting a new database into DevOps is a huge pain because we want to change this column name and now everything breaks or whatever, we want to change the data type. What I typically do, because I'm coming more from a software world where this is much more normal, I abstract this away with using tables and exposing views to my application. So never will I ever have an application connect directly to a table to view data. I always have them connect to a view, because then if I want to change the column name or change the data type, I can just change the view, and that doesn't actually impact the actual data. Because if I want to change the data type, that's going to be a lot more pain, especially from a CI/CD perspective. Here we can leverage the same technique as well. So what I'm going to do is I'm going to rename the customers table to customers base, and then I'm going to rename my customers view to customers. So now let's just run these. Rerun. Now if I go back to my application, oops.
To point to customer base.
Very good. Very sharp, thank you. That's.
Great.
No, the view is now customer. The view is customer. You need to create a new view. Not to create just the other.
Oh.
Yeah.
Thank you very much. Now you can see that I didn't test this part. I tested it with the view because I figured, okay, if I know the view works, I know the demo works. Just remember that if you do it. But now I just have to refresh. Still not. Okay, this is not what I expected. This is not funny. Let's see if this is going to solve it. I'm not sure why this didn't work, because this is not in there. Like this, right? Oh. Okay. I'm not sure why. Oh, yeah, sorry. Yeah. Okay. Great. Thank you guys for paying attention. Lesson for me, always test it. But you can see now, from the phone number, we see the access and we see the actual phone number there visible as well. Just as we saw with Always Encrypted, didn't have to make a change to the application, made some changes to the view as well. It's a common technique, as I said, that I typically use as well. Another one that I use as well is I never grant insert, update, or delete permissions to tables, always through stored procedures. But also because I then abstract away the logic. So if I change the table, I don't necessarily have to change the stored procedure from a client perspective. I can keep all the parameters or the variables that are in the stored procedure, and then inside the stored procedure have the logic that, okay, this variable doesn't exist anymore, or this variable does something else today. And that's very helpful. A question on the screen. Okay, very important one. SQL bits. Due to the issues with the trains, we have decided to bring forward the prize raffles to the last break. So I already had to do an announcement for the prize raffles. raffles at the end of the day. Now, because of train issues, they are being brought forward to 1540. So make sure, I think that's right after this session. Okay. Great. So data masking. Just put it on a view, pretty much works anywhere. This is not specific to SQL. This technology can be used anywhere as well. Now, row-level security. What row-level security does, it fetches the rows from the table, applies the inline table variable function to filter out the result set, and then returns that result set to you. Let's see if we can get that one done as well. And this one's going to be easier because there's less changes. What I'm going to do here is I'm going to create an orders view as well, or alter the orders view, and then do the filtering that the table valued function does as well, but now do it inline in the view. So now I'm going to rename first. And then once it's renamed, I'm going to change the orders view because I've learned something 5 minutes ago. Base, and the rest should stay the same. And again, that's fine. Now I'm going to go back to my application. I actually didn't have to restart it. This should work with. And now we can see Andrew has 648 rows. And if I switch the connection to Janet, I can see that Janet has 127 rows. Because it's the same technique. The same technique SQL 2016 and later uses. It uses that table value function to actually implement the filtering or the predicate. It actually gets attached to your statement. You can see this if you use a execution plan to view the actual execution. You can see that the filtering is applied there. And here we do the same, but we do it in a view. We could also create a table valued function and have that, but that didn't exist in SQL 2000. We could do something else there as well. And that will work. Then the encrypted one. Here you can see that the data is encrypted, decrypted, because I'm getting the wrong one. Let me get back. Let me actually make this change, because I do want to have the encrypted data. So let's execute this. Then here I should only have to refresh. And then I get the encrypted data. But now I want to have that data decrypted from the encrypted column. The column that you just saw is the actual original address column and not the one with encrypted data in it. Because I'm doing it manually, if I enable encryption in SQL 2016 on a column, SQL starts encrypting the data while it's there. So what I actually did for this purpose is I created an additional column, stored the encrypted values in that column, and that's the address encrypted column. Now, if I want to decrypt that data, same applies here. Let me stop my application. And then in my 2000 servers, I'm going to specify that I want to decrypt the data as well. And then run it. And now the data is decrypted from my application as well. And all I'm doing now in my application is that I know how I encrypted the data because I encrypted the data in my application, so I know how I should decrypt the data. What I can also do, the example from Microsoft is using a stored certificate. And I'm using a key that I just created myself, but I could also fetch it from the certificate in the store, if I do have access to the store as well. But one of the drawbacks to that solution is that I do need that store there. And maybe I have an operating system where the store doesn't exist or it works different. On Linux operating systems, we don't have a store like we have one on Windows machines. So it works differently there. And plus, now I know how I decrypted and encrypted the data within my application, and I have control over the keys that I want to use them and how I want to use them. Any questions so far? Thank you. Great. From the bottom, you can see I'm running on SQL 2000. If you don't believe me, then I'm willing to show you as well, just because I can and because it's fun. this is what, if you have never seen it, this is Windows 2008 R2. This is the latest version of Windows that I could run SQL 2000 on. Any newer version will not work.
Do you have Enterprise Manager installed as well?
I have everything installed, and I'm willing to show you this. But this is what's going to happen. If you all recall, we didn't have one management studio in SQL 2000. We had Enterprise Manager and Query Analyzer. This is Enterprise Manager. This is why I'm not showing it to you, because this would have been a very painful experience for everyone. But you can see here the Northwind database is present there. I can see all these old Windows 95 style dialogues, etc. Same for the Query Analyzer. I have that one running here as well. If I can see it. There it is. Connect to the machine. This is how we used to write statements. Actually, I could increase the font here. I did increase the font on this one. But this is what this looked like from select star, from dbo.orders. Change it to the Northwind database, and then execute it. And it's empty because I'm connected as sysadmin, and row-level security works on your username, and sysadmin in the row-level security isn't allowed to see the data. So that's a different one as well, an interesting one as well. But sysobjects doesn't exist, but sysdatabases does. Let's see if we are able to access it from here. No. No, we actually have to access it from master database. And that's it. That's really old school, you know. The system views aren't available in all databases. That's it. What's more interesting to know is that if I want to start another one, new query, I don't have tabbing. So everyone today used to having tabs open. Didn't exist in the early days. We had two windows behind each other. This is how it works. So if you have 15 tabs open today, remember how old people like me did this. Okay, let's go back. Transparent data encryption, we already saw that one. So now, the big question, will it run on SQL 2000? So dynamic data masking, put a mask on the phone column, that's what we wanted to do. In my opinion, we are able to do this. Of course, we have to create a view and we have to create a logic. I could create a function out of that case statement that I'm doing there and then use that function similar to what is happening on SQL 2016 as well, because there they are built-in functions. Row-level security the same. And it's even handier for me to do so because now I'm not relying on the connection. I am in this case, but if I do row-level security from a different perspective, I could maybe send it from the client. So instead of doing it on the view that I'm doing today, I could send in the username from the client as well, which makes it a little bit more easier. Now, always encrypted, that's not possible because I made a huge change to the application. I implemented encryption in my own application. My application itself does the decrypting and the encrypting of the data, stores the key somewhere. So it doesn't work it doesn't work the same way as it works in SQL 2016 and higher. But to me, it's still a success because I would argue that this is much more cleaner. And if I implement things in this way, in this manner, I'm also not tied into my version of SQL. As I showed you, eventually I can get this to work on SQL 2000 as well. But potentially, I could take this same logic to Oracle, to Postgres, and to MySQL. Because I could apply the same logic there. Actually, I could apply the same logic to a parquet table in Databricks. Yes?
And also, let's say because you want to, let's say you have a web application and you want the user only to own the data. You can do that, but you can't do that when it's encrypted because the encryption will be on the web server.
Yeah, and that's very true. So with always encrypted, you always need to be aware that the encryption key is where the client is. So for a web application, it is on the web server that's hosting the application. And here in the example that I'm showing here as well, I have the responsibility of where to store the key. I can choose wherever I want to store the key, fetch the key from there because I don't want to store it on the device, fetch it from there, the decrypted data when needed. Yes?
I was about to ask
Oh, yeah. Any more questions? Yes?
The row-level security, how you change to users, see how you...
No, I didn't change anything on there. I just replicated it on the SQL 2000.
An inner join to a different table.
Yeah, an inner join to the table. I can show you.
There's a different table.
Oh, from the drop-down. Oh, from the drop-down, I'm changing the connection. Yeah. Yeah. So actually, I can show you. It's not a big secret, of course. What I have here, let's stop the application. I have a configuration file where I have all the connection strings, and I'm passing in a different username. And there's different techniques. This is the easiest one by far, because that's what I said. If you want to have row-level security working, you need to have the username passed in. The easiest one is to do this on the connection, so pass the connection on the username. There's also a technique, especially in SQL 2016, where I can do execute as, works as well. I do execute as user, and then the query gets connected to that user, but then I need to append that to every query that I'm sending. But that would work as well, and then there's the concept of an application context where I can set the specific context as well. A drawback of doing this is connection pooling, because the connection is pooled actually on the connection string, and now every user gets his own connection string. But that's definitely one of the reasons why I rarely try to do this, and then use some other logic that I know in my client, and then maybe instead of having a different connection, because I'm having the filtering based on the username, pass in the username as a variable or as a declaration, and then use filter based on that. So, final thoughts. From a security perspective, it's great. I'm not saying in this session, and what I don't want you to take away from this, is that you should disregard any security features in the product today. Because they are far superior and they are really good. And actually the encryption functionality in SQL 2022 has even been further enhanced as well. If it works for you, if it's applicable in your situation, if it allows you to do what you want to do, then please use these, because they are much better to use than what I showed. And also what I showed means I have to make changes to my tables, to my views. If I have 100 tables where I all want to apply masking, I have to create all these view statements on all these tables as well. Although you can quickly create them from a statement, but still. Yes?
Regarding always encrypted and the fact that the certificate comes from the app server, is it generated on the app server, the certificate, or do I have to generate it on the SQL side, deploy it on the application server?
Yeah, so it's a good question. So the certificate that's...
On application
Yeah,
server,
yeah.
for instance, if there is already a TLS 1.2 certificate generated,
Yeah.
can I import it to SQL,
Yeah.
deploy it there and use it?
So let me, so the question is the certificate that's needed for the always encrypted feature, how do we get that certificate, where do we get it from? What I did is by far the easiest way, which luckily today happens in Management Studio. You just right-click, encrypt column, SQL Server does everything for you. What it internally does is create a self-signed certificate, which is not a huge deal for encryption, because we don't want to authenticate the identity. We want to use it for encryption, and then a self-signed certificate could be feasible. You create that certificate gets inserted into SQL and gets loaded into the user store wherever you want to decrypt the data. You could also create a certificate yourself, import that into SQL Server. There's a statement that says create certificate from file, and then you create it from the file. So you have everything you want is possible.
What about in availability rules?
Then you have to replicate the certificate to all the nodes.
They have to get this
Yeah. Security, oh yeah.
Let's see. For always encryption, the thing is, you don't store the encryption key. Well, let's see. It's a bit complicated. I think the key, the key that's in the certificate store is you don't have that on SQL Server unless you want to do encryption on the SQL Server machine.
Yeah, that's correct. You have the thumbprint that identifies the certificate that's needed. So the actual certificate is not there, but for the example that I'm showing here, what a SQL Server does in Management Studio, it creates the certificate in SQL Server, exports it, then removes it, and then imports it into your certificate store, because SQL Server has commands or ways to create the certificate yourself. That's one way, but the proper way is to create a certificate somewhere, get a certificate from somewhere, use that, and then use the thumbprint to set up your always encrypted.
I think what it does when you use the wizard is Management Studio runs the whole thing.
Okay, yeah, that could be. But yeah, that would be the preferred way anyway. Yeah. So what's really important as well, okay, is to provide your feedback. And not forget that the raffle is earlier, so please go there to the raffle. Give your feedback there as well, or enjoy there as well. Give your feedback online, good, bad, as long as it's helping me becoming a better speaker for these sessions. Thank you very much for your attention and your questions and your interactions.